For decades, both scientists and the general public have been captivated by the idea that the universe contains something called a black hole. These mysterious cosmic creatures are able to exert such an enormous amount of gravitational force on their surroundings that not even light can escape their grasp. The gravitational collapse of extremely massive stars is what gives rise to black holes. This process leaves behind an area of spacetime that has an extraordinarily high density. But is it possible that we could one day manufacture a fake black hole right here on Earth? Would it be possible to harness such a vast amount of power in order to get a closer look at these unexplained occurrences? Let's explore the possibilities. It is necessary to first have an understanding of the physics that underpins these cosmological marvels before we can proceed with the building of an artificial black hole. Black holes are formed from the ashes of enormous stars that have run out of nuclear fuel and then collapsed under their own gravity after reaching the end of their life. This collapse leads the center of the star to condense into a singularity, which is a point of infinite density. The singularity is surrounded by an event horizon, which denotes the boundary beyond which nothing can escape the gravitational attraction of the black hole. For an artificial black hole to be formed, a critical density must be reached, which can only be achieved by squeezing an extremely large amount of matter into a very restricted area. This must be done in order to achieve a singularity. However, in order to achieve such severe conditions, one must overcome a great deal of difficulty, both technologically and conceptually. To begin, the quantity of mass that must be present in order to form a black hole is startling. To create a black hole of only a few solar masses, which is on the small side when compared to other objects in the cosmos, we would have to pack more than 3 times the mass of our Sun into an extremely small space. There is no known technology that is currently capable of accomplishing such compression without the application of extremely high gravitational forces at this time. Second, in order to create an artificial black hole, one would need to be able to counteract the immense gravitational forces that are involved. If we wanted to recreate the conditions that are necessary for the production of black holes, we would have to pack an incredible amount of mass into a very tiny area. This would cause the formation of a gravitational field that would be too strong for any known substance or structure to endure. The forces at play would be orders of magnitude beyond anything that humans are now capable of controlling or containing. In addition, even if we were to find a way to manufacture our own artificial black hole, there would still be a great deal of difficulty in regulating it and researching it. The event horizons of black holes are what give them their distinctive appearance. These horizons prevent anything from escaping the gravitational pull of the black hole. This indicates that any information or radiation that was emitted by the artificial black hole would be captured by it and held there. Astrophysicists have a continuing struggle when attempting to observe and understand the inner workings of a black hole from the outside, and the same constraints would apply to an artificial creation if one were to be created. In addition to this, black holes have a significant influence on the area around them, which affects the composition and dynamics of the space-time in the neighborhood. When things approach a black hole's singularity, they undergo a process known as spaghettification, in which they are stretched into long, thin strands due to the high tidal forces that are present around the event horizon of a black hole. It is currently beyond the technical capability of our company to reproduce and maintain control over such effects within a controlled laboratory environment. Although the concept of constructing a man-made black hole may sound exciting, it is still very much in the realm of science fiction at this point. Because of the enormous obstacles presented by the necessary compression of matter, the confinement of gravitational forces, and the restrictions of observation, it is extremely improbable that we will be able to produce artificial black holes and study them in the near future. Despite this, astronomical observations, computer simulations, and theoretical research are still being conducted as part of our ongoing effort to comprehend black holes. We can get vital insights into the fundamental nature of space-time, gravity, and the universe itself if we examine the behavior of natural black holes and the impact that they have on the cosmos. Even though the creation of artificial black holes is out of our reach for the foreseeable future, the information that we glean from the study of their natural analogs will definitely continue to deepen and broaden our comprehension of the cosmos and the strange phenomena that it contains.